Okay, we're still in chapter 1 in geometry. This is problem number 109. We started to get into the idea of reflections and rotations and transformations in general of objects in our geometric plane. So we can translate something, which is when you slide it, left, right, up, down. We can rotate, which is when you spin it around a given point, a certain magnitude. And we can reflect it, which is when you flip it over a particular line or side of the object. And so here we're going to reflect object A across line L here. And so one trick that we can use with reflections is that in reflections, distance is preserved. So if something's a certain distance from one side of the mirror, we'll call it, the reflection is going to be the same distance on the other side of the mirror. So make sure we get a good color here. Okay. So if this particular point is 1 unit away from line L, then its reflection is going to be 1 unit away on the other side. And I'm going to do that with all the major points. Pick this point 2 units away, so 2 units away there. That point is 1 unit away, so 1 unit away there. 1, 2, 3, 4 units away there, so 1, 2, 3, 4 units away there. This point is 1, 2, 3, 4, 5 units away, so 1, 2, 3, 4, 5 units away. And by doing that, I've now created an outline, which if I connect the dots in the same manner in which they are in the original version, we should get a perfect reflection. It would especially be perfect if my lines were straight, but you get the idea. So I'm picking the major points and reflecting them across the line such that distance was preserved. I was able to create the new object perfectly. Okay, we're going to rotate 90 degrees counterclockwise. Okay, so counterclockwise, that's this way. 90 degrees is a quarter turn. So we're going to take this object and we're going to spin it 90 degrees around point P. Okay, to do that, I am going to take each of these points and rotate them first, and then just connect the points at the end. And to do that, I'm going to create almost like a little kind of like pinwheel here, and get the distance that each of those points is from P, and then rotate it. So for instance, this point right here is up to over 3. But when I rotate this 90 degrees, it goes over to down 3. So it's now right there. And so I'm going to call this point A, and I'll call this point A prime, just so I know which one's which. Now from here, I could do that for all the points, right? And I could create this whole big pinwheel thing and get all those little points. But I know the relationship between point A and B and how far apart they are. So I'm going to replicate that relationship in the rotation. So to go from point A to B, that's over 2, down 2. Well, if I replicate that over here, when I rotate it, over 2, down 2, this is where the new location of B is going to be. Same thing to find point C. I know the relationship here between point B and C is down 1, 2, 3, 4, and over 1. So when I take and I rotate that, it's now over 4, up 1 to get this new location of point C. And point D is the same. Right, we have over 2, up 2, so over 2 to there. Connect all of these to get our rotation of figure B. A lot of it's visualization. The more you do, the better you get. In more complicated pictures, we can actually use the locations of the coordinates, and there's rules about where the coordinates reflect to or rotate to. We're not going to get into all the details of that with what we do. Ours is more of a visualization aspect of it. Okay, third one, rotate 180 degrees about point Q. So it doesn't matter if we go clockwise or counterclockwise, it's the same thing. 180 degrees one way is 180 degrees the other way. So we're going to spin this around. And so I'm going to start with this point right here. And if I rotate it 180 degrees around this way, it was 3 units away there, so it's going to be 3 units away there. So I'll call that A, we'll call that A prime. Same thing with this point. If it's 3 units away here, when it rotates around 180 degrees, it's going to be, whoops, 3 units away, 1, 2, 3, 1, 2, 3 over there. So we'll call that point B. So there's B prime. This point, we'll call this C, is 2 units directly below B, which means over here it will be 2 units directly above C. So you already have kind of 2 of the sides here drawn in. There we go. Now, let's go from here. I'm going to use, again, what I know about slope. So we'll call this point D. It's 1, 2, 3, 4 over, 1, 2, 3, 4 up. So when we rotate that from point C over here, it's going to be 1, 2, 3 over, and 1, 2, 3, 4 down. So this is where point D prime is. Looks like that. This point, we'll call it E, is 2 units over from D, so it's going to be 2 units over from D there. This point, we'll call it F, is 2 units up and 2 units over. So 2 units over, 2 units over, point F prime will be right there. And then we kind of connect our dots, and we get our rotated image of C. Again, a lot of visualization using what I knew about slopes, and how those slopes looked when it was rotated in order to find those points. And last one here, reflect D across the line M. So I'm still going to use the trick that distance is preserved. The only thing is I can't just count straight to that line and say, oh, that's 1 unit, because that's not really 1 unit. It's a little longer than 1 unit there. So it'll be difficult to match on the other side. What I can do is figure out how far up and over a particular point is on one side, and that's how far up and over it is from the other. So for instance, if I call this point A, and it is 2 away from the line of reflection, then the reflected point is 2 over from that line of reflection. Same thing here, let's call this point B. It is 1, 2, 3, 4 units above that line of reflection. So 1, 2, 3, 4 units over is where the reflected point B is. So we can connect those already. I have 2 more points. And it works either way. So this one I'm going to go over. So 1, 2, 3, 4, 5, 6. So we'll say point, we'll call this D. Point D is 6 units over, so that means reflected point D is 1, 2, 3, 4, 5, 6 units down. Oh dear, that's a horrible line. Get the idea. We'll call this point C. We know point C is 1, 2, 3 units directly over from D, so 1, 2, 3 units directly over from D. There's C. Not bad. Okay, so there's our reflected image of D. You can see how distance is preserved between there and there, there and there, there and there. If we were to fold it up, all the points match up nicely.